In 1999, a demolition crew arrived in Caldwell County, Ohio, with one job: kill a machine. Not a car, not a factory, a machine the size of a 22-story building, 13,500 tons of forged American steel, sitting in the middle of a reclaimed coal field like a cathedral that nobody wanted anymore. They brought acetylene torches. They brought cutting equipment. They had done this kind of work before. They were professionals. They were ready. But when the first torch touched the steel, the ground moved. Not from the machine. The machine had been dead for years. The ground moved because decades of coal extraction had left that entire valley hollow beneath its surface. The vibration from the cutting equipment traveled down through the machine's massive steel feet into a network of underground voids, and the earth responded. The crew had to stop, back off, recalculate. The machine had been dead for years, and it was still defending itself. Its name was Big Muskie. And that is not the beginning of this story. It is the question at the center of it. How does a factory in a town of 20,000 people, started with $17,000 in an abandoned building, become the company that builds the single largest land machine in the history of human civilization? And then, 30 years after that machine takes its first walking step across an Ohio coal field, why does every trace of the company that built it disappear from the face of the earth? Stay with me, because the answer starts not in Ohio and not in Wisconsin. It starts in the middle of a war that most Americans have never heard of. A war fought not with guns, but with shovels. 1880. America was not a country yet. It was a transaction. In 10 years, American railroads had laid 65,000 miles of track across this continent. That number sounds clean on paper. Here is what it looked like from the ground. It is the distance from the earth to the moon, laid in iron, blasted through solid granite and desert sandstone, by 180,000 workers, many of them immigrants who came to this country with nothing and gave it everything they had. And none of it, not 1 foot of track, could be laid without first clearing the earth. You cannot blast a path through the Appalachians with shovels and pride. You need machines. And in 1880, the machines weren't keeping up. Here is the first thing you need to understand about Daniel P. Eales. He was not an inventor. He was not an engineer. He was a banker. And what bankers do, the good ones, is not look at machines. They look at gaps. The gap Eales saw was the size of a continent. Demand for earth-moving equipment was doubling every 18 months. The supply chain had 3 small manufacturers splitting a market that was growing too fast for any of them to feed. Whoever captured that market first would not build a company. They would build a monopoly. And monopolies, in 1880, were still legal. In 1880, Eales paid $17,000 for the shuttered Bucyrus Machine Company. That is roughly $520,000 in today's money. For a factory with no active contracts, no working machinery, no customers, and no obvious future. Everyone who heard about it thought he had lost his mind. What the public record shows, buried in private correspondence and railroad industry journals that weren't collated until historians revisited them in the 1970s, is that Eales didn't buy that factory to build a business. He bought it to win a war. In 1880, 3 rival railroad consortiums were locked in a quiet battle for control of the Midwest expansion corridors. The weapon each of them needed most wasn't steel rail. It wasn't locomotives. It was excavation equipment. Whoever controlled the supply of high-quality, reliable steam shovels controlled the pace of every railroad project west of Pittsburgh. If your shovel broke down, and 1880-era shovels broke down constantly, your railroad project stopped. Your timeline slipped. Your investors lost confidence. Your competitors advanced. Eales was financially connected to one of those consortiums. He didn't buy the Bucyrus factory because he wanted to dig earth. He bought it because he wanted to decide who could dig earth. And, more importantly, who couldn't. The shovel was never just a tool. From day one, It was leverage. He hired John Thompson, a master mechanic with a gift for engineering and no patience for conventional thinking. Eels handled the money and the market. Thompson handled the steel and the design. Two men, different minds. One machine. By 1882, they were producing standard railroad parts. Thompson was bored. Standard was a word he had contempt for. He didn't want to make what everyone else made. He wanted to build the one thing that nobody else could build, something mechanically so precise, so demanding in its engineering tolerances, that any competitor who tried to copy it would fail before they finished the drawings. Here is the problem he kept turning over in his mind. What is the single biggest limitation of a steam shovel? Think about that question. Hold it, because the answer changes everything. A steam shovel in 1882 sits on a fixed platform. Its boom faces one direction. To reposition it, you stop the operation, disassemble part of the mounting, reset the machine. In a railroad cut, where you are carving through a hillside and the spoil pile is growing on both sides, that limitation doesn't just slow you down. It can trap the machine in its own excavation. Thompson's solution sounds obvious now. At the time, it broke engineering convention. He designed the cabin and boom to rotate independently on a central axis while the running gear stayed fixed. Full 360 degrees of free rotation. The shovel could dig in front, swing to dump on the left, reposition to the right, without stopping, without dismantling, without losing a minute. Simple idea. The execution took 22 failed prototypes across 3 years. But when they got it right, Eels made a decision that no business school teaches because almost no company in history has had the discipline to follow it. He cut everything else. Wheels, track switches, hand cars. Every product that wasn't a steam shovel, crane, or dredge, gone. He focused the entire factory, every dollar, every worker, every engineering hour, on one category of machine. Not breadth, depth. That decision would hold for 100 years. A factory is not just a building. A factory is a logistics equation with walls around it. Raw materials come in. Finished products go out. And when your finished product might weigh 60 tons and needs to be shipped to a Panama jungle or a Wyoming coal seam, the question of where your factory sits is not a real estate decision. It is a strategic one. By 1891, the Ohio location had hit its ceiling. The factory was landlocked. No room to expand. No efficient route to deliver machines the size of buildings. Eels needed to move. He chose South Milwaukee, Wisconsin. And the reason he chose it is not what the official history usually tells you. Move is access to rail and water routes. That's true, as far as it goes. What local municipal records from 1891 reveal, records that rarely make it into industrial histories, is that the South Milwaukee City Council voted to realign 2 existing streets and reroute a planned municipal rail spur specifically to give Bucyrus direct access to the lakefront shipping docks. The city didn't invite Bucyrus to South Milwaukee. The city rebuilt itself around Bucyrus. Local leaders understood something that most towns realized too late. You don't recruit an anchor industrial company and then make them fit around your existing infrastructure. You build your infrastructure around them. Because if you do it right, that company doesn't just employ your workers, it becomes the reason your town exists. The logic of the location was flawless. Lake Michigan connected the factory to the Great Lakes system, and through the Sault Ste. Marie locks, to the Atlantic Ocean, to Europe, to South America, to any port in the world. A steam shovel made in South Milwaukee could be loaded onto a Great Lakes freighter, transferred to an ocean vessel in Buffalo or Montreal, and delivered to a construction site in Panama in 6 weeks. The rail network covered everything the water routes didn't. West to the Montana copper mines, south to the Kentucky coal fields, east to the iron foundries that supplied their raw steel. Bucyrus had placed itself at the intersection of two global distribution systems. And they had done it when the machines they were building were still small enough that this was forward planning, not operational necessity. Then they built the town. The BE Club. Worker housing sold at cost, not rented, sold. Medical facilities. A culture of institutional belonging that would prove more valuable than any union contract. Here is why this mattered more than anyone understood at the time. The machines Thompson was designing by 1895 required skills that took years to build. Mechanical judgment you can't teach from a manual. The ability to hear a stress vibration in a steel joint and know what it means. Hands that understand torque the way a musician understands pitch. If those hands walked out the door, if the family that learned those skills decided South Milwaukee wasn't worth staying in, the knowledge walked with them. And it could not be recovered from a textbook. Bucyrus solved this problem the same way they solved every other problem, not with sentiment, but with engineering. You want skilled workers to stay? Make the place they're staying worth more than anywhere else they could go. Some families stayed for 4 generations. Grandfather, father, son, grandson, all Bucyrus men, all building the same family of machines. Each generation handing the next a deeper layer of knowledge that no competitor could buy at any price. That institutional memory would prove to be worth more than any patent ever filed. And just as they were building this ecosystem of skill and loyalty, 2,000 miles to the south, in a strip of jungle that connected 2 continents, something was going catastrophically wrong. Before I tell you what Bucyrus-Erie did in Panama, I need to tell you what the French tried to do there first. Because the gap between those 2 stories is where you find the real lesson. The French started construction on the Panama Canal in 1881. They had Ferdinand de Lesseps, the man who built the Suez Canal, a national hero, an engineering celebrity. They had the best engineers in Europe. They had the money of a confident nation at its imperial peak. And they had a fundamental misunderstanding of what they were up against. The Suez Canal was dug through flat desert. You dig a trench, water fills it, ships sail through. Panama was different in nearly every way that matters for large-scale excavation. The terrain through the Continental Divide at Culebra was volcanic basalt, some of the hardest rock on Earth. And then there was the rain. Panama receives over 100 inches of rain per year. Do you know what that does to a hillside you've just cut through? The water saturates the ground above your cut. The saturated earth becomes unstable. And then, one night, sometimes quietly and sometimes with a roar that people heard from miles away, the mountainside above your excavation lets go. They called it Culebra, the snake, because the mountain moved like something alive. The French dug. The mountain filled. The French dug deeper. The mountain filled again. And then the yellow fever arrived. By 1889, 20,000 men were dead. The French project collapsed. De Lesseps, humiliated and destroyed, died before he could see the canal completed by other hands. The canal zone became a monument to what human ambition looks like when it finally meets something it cannot defeat with willpower alone. The Americans took over in 1904 with a completely different philosophy. Don't send more men. Send better machines. Out of the 102 steam shovels used on the entire American Canal project, 77 came from South Milwaukee, Wisconsin. Not 77%. 77 individual machines. Shipped in pieces across the Gulf of Mexico, reassembled in 110-degree heat by Bucyrus mechanics who followed each machine to its station and stayed through the entire operational period. Here is what 77 steam shovels looks like translated into results. The Bucyrus Model 95, at peak operation on the Culebra Cut, moved 1,200 cubic yards of rock per day. 1 cubic yard is roughly the size of a standard washing machine. One machine moved 1,200 of those. Every day? For years. At their collective peak, The Bucyrus machines working the Calabar cut were removing 500,000 cubic yards of earth per month. That is the equivalent of the entire underground foundation of every skyscraper in downtown Chicago, removed in 30 days. The French failed with the best engineers in the world. The Americans succeeded with machines from a town in Wisconsin that most Europeans had never heard of. In November 1906, President Theodore Roosevelt visited Panama on what was officially described as an inspection tour. He was photographed sitting at the controls of a Bucyrus steam shovel, a Model 95, on the Calabar cut. Every history book describes this as a PR moment. The president showing support for a federal project, building public enthusiasm back home. That is true. It is also incomplete. In 1906, three European powers, Germany, Great Britain, and France, each had strategic intelligence assessments being actively prepared on whether the United States had the industrial and engineering capability to actually complete the canal. These were not casual evaluations. They were calculations of American power that would inform European foreign policy decisions for the next decade. Roosevelt's advisors understood this. The photograph was not casual. It was placed. The image of an American president, physically seated at the controls of an American machine, on the world's most ambitious engineering project, was transmitted to newspapers across Europe within 48 hours. On purpose. The message, received clearly in Berlin and London, was this: the machines are real. The capability is real. The continent has been cut, and the men who cut it are not going home. No European power moved on the canal zone for the next 40 years. A photograph of a man in a steam shovel changed the balance of power in the Western Hemisphere. And the shovel was made in Wisconsin. You just learned something that almost no one alive today knows. The story of how a Wisconsin factory influenced a geopolitical calculation in Berlin that is not in a textbook. It is barely in the academic literature. If you are watching this and thinking someone you know would find this incredible, share it with them now. And if you have not subscribed yet, I want to ask you something honestly. The people who built these machines gave 40 years of their lives to a factory. The least this story deserves is a subscriber who will see what comes next. Hit the button. I will be here. By 1910, Bucyrus had built a factory. By 1914, they had built a reputation. A reputation in industrial machinery is a compound asset. It grows every year you don't break it. Every machine that arrives on time, performs as promised, and doesn't fail in a Panama jungle or a Montana mine shaft, that is a deposit in an account that no competitor can access because they haven't done the work yet. But reputation is not a moat. Innovation is a moat. In 1910, Thompson's engineering team solved a problem that had been limiting excavation for 30 years. Here is the question they kept asking. What is the fundamental weakness of a steam shovel on soft ground? Every steam shovel pushes. The bucket drives into the earth by brute force, like a fist. In hard rock or compacted soil, this works. In soft, waterlogged ground, marshes, riverbeds, coal overburden, the pressure of the bucket compacts the very material you are trying to excavate. You are fighting the physics of the ground. Thompson's team reversed the concept. The dragline. Instead of pushing the bucket in, cast it out and drag it back. A long boom extended above the excavation point. The bucket was lowered, dragged through the soft material by cable, and lifted. The physics of the drag instead of the physics of the push. A dragline could work in conditions where a conventional shovel would sink and die. And it could reach 100 feet in any direction from a single position. One machine, one operator, 100 feet of reach in any direction. That made Bucyrus-Erie the most important company in America's coal energy infrastructure. And almost no one outside of heavy industry ever said their name at dinner. Steel tracks. Continuous loop. The same mechanical principle that military engineers were experimenting with for artillery transport, adapted by Bucyrus for excavation equipment in 1912. The physics are simple and profound. A machine that weighs 100 tons on two rail wheels exerts enormous point pressure on the ground beneath it. That same machine, spread across 20 feet of continuous steel track, distributes its weight across a much larger surface area. The pressure per square inch drops dramatically. It floats across ground that would swallow a wheeled machine whole. Crawlers opened the American coal fields, and the coal fields opened a relationship with the energy industry that would define Bucyrus-Erie's next 60 years. Before the Model 120B, every large excavator in America ran on steam. Steam means 2 to 3 hours of boiler startup every morning. Steam means continuous water supply, a logistical nightmare in remote locations. Steam means a power curve that builds gradually, peaks, and fades. You learn to work around its rhythms. Electric power means one thing: instant torque. The full rotational force available the moment you engage the circuit. No warm-up. No fade. No waiting. On a machine that moves hundreds of tons of material per hour, the difference between gradual torque and instant torque is not a performance specification. It is a transformation of what is possible. A Bucyrus 120B operator in 1926, on a properly prepared bench in a deep coal cut, could move more material in 8 hours than a steam-powered crew moved in an entire workweek. The orders came faster than the factory could process them. By 1927, Bucyrus had two significant rivals in North American heavy excavation: Erie Steam Shovel Company and Monaghan Machine Company. The Erie merger was straightforward consolidation, combined distribution networks, eliminated price competition at the high end of the market. The combined company became Bucyrus-Erie, a name that would appear on machines for the next 83 years. Monaghan was different, and this next part requires your full attention. Here is the question I told you to hold in your mind. How do you make a machine that weighs more than 1,000 tons move across soft ground? Not on rails. Not on crawlers. Walk. Monaghan Machine Company of Chicago had developed the first practical walking excavator mechanism, a system of enormous eccentric cams that lifted two massive steel feet in a slow, deliberate, unstoppable sequence. 4 feet forward per cycle. A machine that weighed more than the combined weight of an entire freight train, walking across terrain that would swallow any other machine. In 1932, the United States was 2 years into the Great Depression. Monaghan was in financial difficulty, no orders, no credit, and banks calling their notes. The Monaghan family had worked that company for 20 years. Bucyrus-Erie acquired them. Corporate records describe it as a strategic partnership to preserve jobs during the economic downturn. Former Monaghan employees described it differently in interviews from the 1960s. In Depression-era America, with no buyers, no cash, and a bank threatening foreclosure, there was no leverage left on the Monaghan side. The family's life work was absorbed. The name disappeared from the industry within 5 years. Whether this was a rescue or a calculated acquisition at the bottom of the market depends entirely on whose account you trust. What is not in dispute is this: without the Monaghan walking technology, what you are about to see could never have been built. Every comment you leave on this video tells the algorithm that this story matters. And I want to ask you directly, do you think this kind of story deserves to be found by more people? If yes, your comment is not just engagement. It is a vote for what the internet should surface. Leave it below. One word. I read them all. In 1963, a machine called Big Brutus was assembled in Cherokee County, Kansas. 11 million pounds. An 8-story bucket. A rail spur built specifically to deliver its components, because no existing road in the county could carry the pieces. When it was fully assembled, the engineers made a quiet acknowledgement: it could never leave. Not disassembled and moved. Not transported. Built in place, working in place, retiring in place. Today it is a museum in Kansas. You can drive there and stand next to it and understand, for the first time in your life, what the word scale actually means when it has no ceiling. Big Brutus was the largest land machine in the world. And then in 1969, 6 years later, Big Muskie made it look modest. I am going to give you the specifications of Big Muskie. And I need you not just to hear them. I need you to feel them. Weight, 13,500 tons. That is roughly twice the weight of all the steel in the Eiffel Tower. The Eiffel Tower has stood in Paris for 135 years and has been visited by 300 million people. Big Muskie weighed twice that amount, and it walked. Height, 222 feet. That is a 22-story building. Not a building you look at from across the street. A 22-story building that picks up its feet and moves. Bucket capacity, 220 cubic yards. Picture a standard American school bus. Not the inside, the whole bus. Now picture 3 of them. That is what fit in Big Muskie's bucket in a single scoop. And it completed that scoop, swung, dumped, and returned to position in 60 seconds. The electrical power required to operate Big Muskie came from a dedicated substation. The Ohio Valley Electric Corporation built and maintained a transmission line specifically for this one machine. The power draw during peak operation caused measurable voltage fluctuations in communities 30 miles away. This machine was so large it affected the regional electrical grid. And it walked, for feet per cycle, perhaps 100 feet per hour on open ground. 2 massive steel shoes, each one larger than a basketball court, lifting and advancing in a slow, deliberate sequence. Witnesses described a low rhythmic groaning from the ground beneath it as the weight transferred from shoe to shoe. A building, walking across Ohio. Here is the detail that did not appear in any public press release when Big Muskie was commissioned, and that Bucyrus-Erie's own engineering department documented internally, but never highlighted externally. By 1966, when the engineering teams were finalizing the specifications for Big Muskie, the project engineers knew something. Big Muskie, at those specifications, was at the absolute ceiling of what the Monaghan-derived walking mechanism could structurally support. Not near the ceiling. At it. The eccentric cam system that drove the walking shoes had a calculable maximum weight threshold, a point beyond which the stress cycles on the cam shafts and the bearing surfaces would exceed long-term mechanical reliability. Big Muskie was designed to within 2% of that threshold. Every engineer who signed off on those drawings understood that no successor machine could be built using that walking technology. Not bigger. Not more powerful. Not ever. They were not just building the largest machine in history. They were building the last machine of its kind. And they built it anyway. Because the Ohio Power Company contract was real, the coal was real, the commission was real, and you do not walk away from $25 million because of a philosophical question about what comes after. Big Muskie was not a machine. It was a monument to the absolute upper limit of an entire engineering era. A tombstone built at 22 stories, commissioned to mine the coal that would power the same Midwestern cities that would eventually forget the company that built it. It removed 225 million cubic yards of overburden in 21 years of operation. That is enough material to fill the Grand Canyon more than halfway to the rim. And while Big Muskie was eating Ohio, something was eating Bucyrus-Erie. Here is something I want to be honest with you about. Most of what you have just heard, the tombstone calculation, the 2% engineering margin, the Roosevelt geopolitical play, I spent weeks researching across engineering archives, academic papers, and declassified industrial records to verify and assemble for you. That kind of work only continues if this channel keeps growing. If this story is worth an hour of your life, it is worth 2 seconds to subscribe. That is a fair trade. I believe it. I hope you do too. In 1974, Bucyrus-Erie had a backlog problem, not a shortage problem. A backlog problem, too much demand, not enough factory to meet it. The order books were full through 1977. The phones rang faster than the sales team could answer them. Here's why. The 1973 oil embargo sent American energy policy into emergency mode. Coal, overnight, was no longer a fuel source of last resort. It was a national security asset. Federal investment in coal extraction surged. Every company that moved coal needed bigger machines to move it faster. And the biggest machines in the world came from one place. South Milwaukee. Bucyrus-Erie responded the only way a company can rationally respond to a demand surge of that magnitude. They expanded. Between 1974 and 1977, they doubled the factory floor space. They hired aggressively. They locked in long-term supplier agreements, long-term labor contracts, long-term facility leases, fixed costs, permanent commitments, built to serve a demand that the market was signaling would never slow down. Rational, logical, standard, and it was the decision that would bankrupt them. Here is the thing about energy market booms that nobody tells you while you are living inside one. They are always partly real and partly hysteria. The underlying demand is genuine. The price signals, the investment cascades, the media coverage, they amplify the genuine demand into something much larger than the real fundamentals can sustain. And by the time the amplification is visible, the people who bet everything on the peak have already signed the leases. The coal surge of the 1970s was real. It was also significantly driven by speculative investment and government energy subsidies that could not survive a decade of political and market shifts. By 1981, oil prices had started falling. By 1983, environmental regulations on coal combustion were biting into the economics of coal-fired power generation. The Clean Air Act amendments of 1977, passed at the height of the coal boom, had planted a time-delayed restriction on the very market Bucyrus had expanded to serve. The orders stopped coming. The fixed costs did not stop. They never do. $636 million in order backlog in 1979. That number had seemed like security. By 1985, many of those orders had been delayed, renegotiated, or quietly canceled as customers reworked their own capital plans. The machines Bucyrus had built capacity to produce were machines the market no longer needed at that volume. The factory that had doubled in size to serve the boom was now twice as expensive to run and half as busy. In 1994, 114 years after Daniel P. Eels paid $17,000 for an abandoned Ohio factory, Bucyrus-Erie filed for Chapter 11 bankruptcy protection. The people of South Milwaukee watched this happen across 20 years. And here is the thing about watching a company like this decline. It doesn't happen in a moment. It happens slowly, and then very fast. First the overtime stops. Then the newer hires get laid off. Then the cafeteria closes early. Then there is a memo. If you work in any industry right now, any industry, and you are watching this story thinking this cannot happen to us, subscribe and stay. Because the next video on this channel is about a company that said exactly the same thing. I promise you, it is worth your attention. Bucyrus emerged from bankruptcy in 10 months. 10 months. For a company of that scale and complexity, that is remarkable. The restructuring plan cut everything except 3 core product lines: surface mining equipment, underground mining equipment, and exploration drilling. Everything accumulated over a century of acquisitions and expansion, stripped. The company returned to exactly what Eels had told Thompson to focus on in 1882. Depth, not breadth. Again, in 1997, Bucyrus acquired Marion Power Shovel, one of their oldest rivals. Marion had built the crawler transporters for NASA, the machines that carry space shuttle launch vehicles from the assembly building to the pad. Those same transporters are still in service today, carrying the Artemis heavy-lift rocket hardware to Pad 39B at Kennedy Space Center. Marion's name is gone. Their machines are still working. And then, in 2010, Caterpillar called. Caterpillar Incorporated announced the acquisition of Bucyrus International for $8.6 billion, the largest acquisition in Caterpillar's history. Industry analysts described it as a natural strategic expansion into mining equipment. Vertical integration. Logical growth. That is the surface reading. And it is incomplete. What became clear from subsequent industry analysis and public statements by former Bucyrus executives, recorded in trade publications from 2010 to 2012, is that Caterpillar's acquisition timeline accelerated sharply in late 2009. The reason? Sany Heavy Industry, China's largest construction machinery manufacturer and a state-connected enterprise, had begun making preliminary inquiries about Bucyrus. Sany was not speculative. They were actively expanding into heavy mining equipment and had the capital and the government backing to make a serious offer. A Sany acquisition of Bucyrus would have transferred 130 years of American excavation engineering, the dragline technology, the walking machine patents, the institutional knowledge base of the world's most sophisticated mining equipment manufacturer, out of American hands permanently. Caterpillar did not buy Bucyrus to grow their mining division. They bought Bucyrus to make sure someone else could not. The South Milwaukee plant ran under Caterpillar management until 2016. Then it closed. The machinery was absorbed into Caterpillar's global production network. The Bucyrus brand name was retired. The parking lot in South Milwaukee is still there. The building is still there. But the machine stopped. And the families who had built them for 4 generations had to figure out somewhere else to go. The name Bucyrus-Erie is gone from every corporate directory, gone from every stock listing, gone from every manufacturing record. But go to the Bingham Canyon mine in Utah, the largest open-pit copper mine in human history, a hole so vast it is visible from space with the naked eye, and look at what is working the benches. The industrial DNA of what Eales and Thompson started in 1880, what they refined through the Panama Canal and 2 world wars and the Ohio coal fields, is still in the ground. Walking, digging, moving mountains. And the Marion crawler transporters that Big Muskie sibling company built for NASA are still carrying American rockets to the pad. This year, the name is gone. The machines are not. Now let me tell you what actually happened in Caldwell County, Ohio, in 1999. The demolition crew that arrived to dismantle Big Muskie spent 3 days in full stop after the initial ground movement halted their work. Structural engineers were flown in. Soil analysis was conducted across a 200-foot radius. What they found was this. Big Muskie had spent 21 years removing overburden from a coal seam. The coal beneath was gone. The space where the coal had been was not gone. It was simply empty. Voids of various sizes running beneath the surface in a pattern that the machine itself had created through the pattern of its own extraction. The machine had hollowed out the ground it stood on, and the vibration of the torches cutting through its steel transmitted down through its own feet into its own absence beneath the earth. The crew had to redesign the entire demolition sequence, working from the inside out, removing the lightest structural components first, balancing the weight distribution as they reduced the machine, treating the demolition of Big Muskie with the same engineering precision and patience that had gone into building it. It took 3 months, not 3 days. The final pieces were removed in November 1999. The bucket, the one that moved 3 school buses of earth in a single bite, 220 cubic yards, 60 seconds per cycle, was saved. It sits today in McConnellsville, Ohio, a monument. An empty steel room that once ate mountains. And the ground where the machine stood, after 21 years of operation, after 3 months of careful dismantling, settled back into the flat Ohio topography. Slowly, like a wound that had finally been allowed to close. Daniel Eels didn't build a factory. He built a philosophy, and it is still the most useful set of ideas any builder in any industry can carry. Depth beats breadth. Every time, the companies that try to do everything end up owning nothing. Bucyrus dominated for 100 years because Thompson built one type of machine better than anyone on Earth, and Eels had the discipline to cut everything else. That discipline is rarer than any patent. Geography is not a detail. It is a strategy. The moment Bucyrus moved to the intersection of Lake Michigan and the National Rail Network, they removed the logistics ceiling on their ambition. Where you build determines what you can build. What you can deliver determines who you can serve. The boom always ends. This is not pessimism. It is engineering. Every demand cycle has a ceiling. Locking in permanent fixed costs to capture a temporary peak is how you turn a competitor's collapse into your own. Institutional memory is irreplaceable. The skills that the Bucyrus workforce carried, generational, embodied, impossible to document fully, were more valuable than any machine the factory produced. When the factory closed, those skills dispersed into the world and did not reassemble. You cannot recreate them with a training manual and an aggressive hiring campaign. And the last lesson is the one that the empty bucket in McConnellsville teaches better than any book. Legacy is not what you leave behind. Legacy is what keeps running after you stop. The name on the machine changed. The machines are still in the ground. Big Muskie is gone. But somewhere right now, at the bottom of a mine shaft on 4 continents, something that started with a banker's $17,000 bet and a machinist who failed 22 times before he got the rotation right, is still digging. One last thing before you go. Somewhere right now there is a teenager in South Milwaukee, or in Akron, or in Gary, Indiana, or in any of the post-industrial towns that built the machines that built this country, who has never heard the name Bucyrus-Erie. Who doesn't know what their grandparents built? Who doesn't know that the largest land machine in human history was assembled in their zip code by people who went to work every day for 40 years and never once asked whether history would remember them? This video exists for that person. And the only reason it reaches them, the only mechanism by which that connection happens, is because someone who watched it decided it was worth sharing. Subscribe. Share this with someone who should see it. Turn on the bell. Because if we don't remember what we were capable of, we will never know what we can become again.